Let's get started. Welcome to day 2 of Build. My name is Sudhakar Senakela. My team and I are responsible for open source databases in Azure, and we're also responsible for database migrations to Azure. So today's topic is how do we build cloud-native applications using MySQL and build large-scale applications. Today's agenda, I'll kick off by talking a little bit about our journey building open source databases in Azure. And the majority of the conversation today will have one of our customers, HSBC, coming on stage and talking about their experience building a large-scale mission-critical application on Azure and using MySQL and a bunch of other Azure services and kind of walk you through the journey and the lessons that they've learned. Now, when customers decide the choice of databases they want to use for their applications, typically it starts out by understanding the needs of the applications, the capability of the databases, the experience and skill set of developers within the companies, and also the total cost of ownership. So our journey started about 2 years ago when we had a lot of customers wanting us to support open source databases on Azure in a managed fashion. Stack Overflow is a company that does surveys with developers, and they released their annual report. Over the last 3 years, there's been a huge surge in the usage of Postgres, MySQL, and MariaDB. So it's a clear signal that developers are betting big time on open source databases. So about a year ago, we made MySQL and Postgres generally available on Azure, and a few months after that, we had MariaDB available in Azure as well. Our strategy and goal here is to provide a choice of databases, popular open source databases for customers so that they can build amazing applications. So over the last 1 year, the response from developers have been really overwhelming, and I really thank you and your peers for developing amazing apps using open source databases in Azure. Now, why do customers like open source databases in Azure, right? There are a few reasons. I'll kind of walk them through it. First one is we made a design decision to support community editions of databases on Azure. The reason for doing that is to make it easy for developers and customers to be able to migrate open source databases running on-premises or other public and private clouds to Azure. And the second reason is we want to make sure that the customers don't feel that they're locked into a particular vendor. So one of the challenges with proprietary databases, portability of workloads from one cloud to the other or on-premise to a private cloud, makes it harder when you're betting on proprietary databases. So this is the reason why we wanted to stay true to the community editions of these open source databases. The next reason why customers like these open source databases in Azure is the way we designed the system. We offer 4 nines of availability, SLA availability, in a single availability zone configuration. In fact, Azure is the only cloud that provides 4 nines of availability in a single AZ configuration. And I'll talk a little bit about this. So what it means from a total cost of ownership is essentially, if you're running open source databases on Azure, it's typically half the price of you running these databases on another public cloud. The third area that customers get excited about, and we've got a lot of positive feedback on this, is the security and compliance features for open source databases, MySQL and Azure. Azure has the most amount of compliance certification than any other public cloud provider in the world. And also, Azure has some unique benefits like Azure IP Advantage, where our customers and developers can run open source software on Azure without any legal ramifications. The fourth area is we invested a lot in built-in intelligence for performance and security. And you'll see a demo of that later today on how HSBC is leveraging some of the intelligent insights and security features that we provide out of the box for these managed offerings in Azure. And finally, the fact that we are running community editions of these databases, we naturally support most of the common language frameworks and languages like Drupal, Joomla, WordPress, PHP, Python, so on and so forth. So this is something that developers like because they're used to the languages and tools that they're used to. They easily interop with the service that we offer in Azure. And the other area where the team did a lot of work is around easy integration with the rest of Azure services, because we know developers, when they develop applications, they think about the entire stack. So we want to make it easy for developers using Azure App Services or Azure Container Service to be able to easily interop with open source databases in Azure. So these are a few reasons, and based on the feedback from customers, that they like building applications on open source database in Azure. And thanks to the great applications developed by developers, we are one of the fastest growing services in Azure in terms of customer adoption. Let me dig in a little bit about open the hood and under the covers, talk a little bit about how we designed our managed offering for MySQL and MariaDB on Azure. If you notice on the right-hand side, we have the applications, MySQL or MariaDB, connecting to a gateway. And the gateway node connects to the MySQL compute node. And we run these databases in a multi-tenancy model in a secure container. And the compute node connects up to the remote storage. And we have 3 copies of the data for redundancy. So let me walk you through a couple of scenarios. In the case of high availability, if a storage stamp goes down, we automatically spin up another storage stamp here. And this operation is it's an online operation, completely transparent to the end application, because the end applications maintains the connection string to the gateway, and anything that happens under the hood is transparent. In case a compute node goes down, since we operate the MySQL database in a secure container, we can immediately spin up a new compute container in a matter of a few seconds. So if you notice, the client is connecting to the gateway, and as long as the application has some retry logic for a few seconds, this appears as an online operation for the end application. And we have a management service called Azure Database Management Service that constantly monitors the overall health of the system and takes remediative and corrective actions. We have machine learning models that sit on these management service that run predictive algorithms to predict in case your storage stamp or a compute node goes down, so that we can take corrective actions even before you run into issues. Because of this architecture, we have the capability to automatically scale your compute node and storage based on the size and shape of your workloads, because we do understand that customer workloads vary based on seasons and time of the day. So because of this architecture, if you're expecting a lot of data ingested into the database, you can scale up your data storage from, let's say, 2 terabytes to, let's say, 4 terabytes. And that appears as an online operation from the end application. So essentially, there's zero downtime. Similarly, if you're expecting a lot of workloads come in, if your compute CPU is running hot, you can scale up the number of vCores running on this database, and that's an online operation as long as you have retry logic built into your client driver and client application. So this is very appealing to customers. Like, as I said, the built-in HA, the ability to scale up compute and storage in an online fashion is very appealing to customers. And also, as I mentioned, because of this architecture, now you can get 4 nines of availability at half the price of running these MySQL on other potential public clouds. Because in other public clouds, you need a multi-AZ configuration. What that means is your costs automatically double, right? So this is actually very exciting to our customers, and the feedback that we got from developers and customers has been overwhelming. And HSBC is one of our customers. They've built a mission-critical application running 500 million plus transactions a day using our MySQL service. And so let me roll a video, and then I'll invite HSBC on stage. Let me introduce Alessio Basso, Chief Architect of HSBC.
Thank you, Sudhakar.
Hey, welcome.
Hey. Thanks. Hi. Thanks, everyone. I'm here to explain you a bit more of who we are, what do we do, and exactly what we did with Microsoft team with regard to MySQL and tuning the service. So first of all, a couple of words about HSBC. Who are we? We are one of the world's largest financial institutions. We have more than 40 million customers in 66 countries. And we have been around for 154 years. So we have quite a substantial footprint. For instance, we run our own data centers in 21 countries, which is quite interesting if you consider that we run this application particularly on the cloud, so not on our own data centers. PayMe, the application that you just saw on the video, is part of HSBC. It's a social P2P application that we launched in the Hong Kong market about a year and a half ago. So first of all, why did we launch PayMe? 2 years ago, the bank realized that we were struggling to connect with our youngest demographic, specifically with the millennials. They want to do everything via mobile, and the bank was just not set up for that. On top of that, the Hong Kong regulator issued a new license, a so-called store value facility license, that opened the market to competition from not only banks, but also non-financial players like the China technology giants. So we had to do something to protect Hong Kong as our major market from this competition. This something was PayMe. As you saw in the video, we started with P2P, and we recently released PayMe for Business, which is a tool that businesses can use to grow their business and accept payments from PayMe customers, both online and in store. So we were set up as a startup within a big organization, and we had a blank slate. We could decide to adopt any of the solution and infrastructure that the bank have, those 21 data centers around the world that I mentioned before, or not. So it was completely our choice. When we started, we decided to set first some goals, some success criteria that we evaluated in order to pick our technology stack. The first one was that we wanted to achieve effortless auto-scaling. We wanted to set up our environment and then let the user grow, let the usage grow, and not having to think about it. On top of that, we wanted to break away from the traditional way of processing transaction and moving money in the bank, which is nightly batch, and then you get your money after 2 or 3 days, which is typically how credit card works. Like settlement, it's not always real time. And we wanted this to be fast. Like our goal was that every single interaction with the platform, and I don't say transaction because we'll see later what transaction means, needs to be completed within 300 milliseconds, so very, very, very fast. On top of that, and that's the latest and most important goal, is we wanted to have access to this data. So the data should not be locked in a transactional database in a format that we cannot use. We want to give this data to our data scientists, our data analysts, so that they can generate insights for our customers. So this was the goal, what we wanted to achieve. And you see that these 3 conditions pretty much rule out deploying on our own data centers. So we had to decide on the tech stack, and how do we decide on the tech stack? So typically, for who of you works in a big organization, you know that you have 2 options, right? You either go and you create a very, very detailed analysis, and typically you always pick 3 options or more for every single component of your technology stack. Then you write down a very detailed list of all the capabilities, and you rank each option against those capabilities. And then you decide. The reality, though, is that most of the times you can't decide because you have too much information and it's not actionable. You just get lost in it. So what you do is you typically create an executive summary, which is a summary of all this information distilled in 1 page for easy decision. The reality is that you can't summarize all this detailed analysis in 1 page. So you, of course, lose some of this detailed information. So you may make decisions that are misleading because they're based on only a subset of your data. So you have 2 extremes, right? What do you do? We decided to take a middle approach. So we did set for ourselves principles, and then we went to Azure. and we tried a number of services that we thought were fit for purpose for us at that time, and then we just went live with it without too much design. So before we go on, let me tell you what a principle is for us. For instance, we will use managed services. It's a principle. We don't want to manage a mess with infrastructure, security patching, and stuff like that. We shall automate all the provisioning, infrastructure provisioning is a principle, right? So we had this principle to guide us in the selection of both the tech stack as well as the software. We may develop our own software or acquire software from a vendor. Because we had these principles and because of the approach that we took, the adoption journey for a number of our services has not been so linear. So we didn't pick Azure MySQL at first, for instance. And this is true for all the 4 major areas that compose our technology stack. For instance, application deployment. Again, we went through a journey. We tried to deploy our application in several fashions before we got to AKS, which is where we are now. The same is true for the transactional database. Again, we didn't start with Azure MySQL at that time. The same is true for our analytical database, and Barney will speak a bit more about that later. The same is true for our analytical platform. So let's go and look at every one of these 4 journeys a bit more in detail. So application deployment. When we started, our to-do list was gigantic. So we had a lot of things to do, and we didn't want to spend any time thinking about how to host our application. So it was a Java application, so we didn't have microservices at that time. It was a small monolith. The easy choice was app service. You drop your binary, it works, fantastic. It was very easy to start with, so we picked app service. It was OK for about a year. And then, as I mentioned before, circumstances changed, and we had to move away from it. What changes for us was we had to use the isolated version of app service, and we had some issues related to the speed of scaling when we had to approximate daily peaks of traffic. So it wasn't quite fast. Like you expect a scaling in 2 minutes, it took 20 sometimes, so it didn't quite work out for us. As well as we had to import our own runtime because we were using some specific version of Tomcat and some libraries that we had to have that in a particular version. And it wasn't working very well for us, the way app service managed bring your own runtime. So we had to move away. And that was our first mistake because we didn't follow our initial principle, which is we always use managed services. And we decided to deploy on virtual machines. All our developers were familiar with that, so it was like it seems the right choice. The reality is that first, we had to spend a lot of effort of creating a process and a mechanism, an approval process and a verification process related to security patching of the operating system. So exactly what we didn't want to do, according to our principle. The second problem is that we had to write a lot of hacky scripts to deploy our application and to manage things like red-black deployments and things like that. App service give you stage deployments, and you can redirect a percentage of users to a new version of our application, and that's all provided, right? We had to recreate exactly the same thing homegrown, basically, and that wasn't working very well. So after like a couple of months, it didn't last very well. We moved out, and we decided to go into containers. So containers solve one problem. Well, the container solution that we use, which is a CS engine, solved one problem, which was use of standard tools for packaging and deployment. Everything was packaged in a Docker container, so all the problems that we have with the custom runtime were solved. And we could use Spinnaker to do deployment. So all the different fashion of rolling red-black was provided. We still had a problem on VMs. So again, last step, and we went to AKS. It's still not perfect, mainly because you can't still create a totally private cluster. You still have to allow outbound internet communication, and the control plane is available on the internet, so that much. But it's OK for us. So Let's spend like a minute or two looking a bit in detail of what the microservice for us look like. There are 3 points that I want to highlight. The first one is that for us, a microservice is a totally isolated unit of deployment. When I say totally isolated, that means that the application and every single Azure service that the application uses is dedicated to that service. So it's a given that a microservice has its own data store. It's probably not a given that a microservice has its own version of, its own instance of storage, AD, event hub for events. So it's all specific to the service. In a big organization, though, and I'm sure that some of you may relate to, you sometimes have specialized teams that wants to manage a piece of your infrastructure. Like in our case, we had a crypto services team that on-prem manages all the HSM and all the operations related to data encryption keys, and they want to do the same for cloud. So the ask was, you put all the key vault on a different VNet, which is on a different subscription to which we do not have access, and the central team manages everything that's related to key, like key rolling, key issuance, and stuff like that. And this is true for all the services. We realized, though, that doing this was kind of breaking our principle that a service is an isolated unit of deployment, because, you see, both services, A and B, have an external dependency to the key vault. And that's an opaque dependencies for us, because we don't know what's going on there. So we don't even know, are they using one key vault per service, or are they using one single key vault where every key related to every service is just there together? We don't know. We don't control it, right? So we decided to flip the equation, and we decided to create also key vault as part of our subscription. Again, one key vault per service, and to give access to the external team via service principals and policies. So they can do their operation, rolling keys, creating keys, but we still own the infrastructure. So that's the first point that I want to make. The second point is that sometimes you have services that insist on the same database logically. Well, we split that as well. In our case, we have a payment transaction microservice that does every operation that's related to making transaction, and then a payment reporting microservice that does all the read operations related to transactions, like get a balance or get a list of transactions, things like that. They logically insist on the same database. What we did is to split it. So the payment transaction writes on the master database for that microservice, and the payment reporting insists on a read replica. So although logically it's the same database, we let Azure MySQL manage the read replicas, and they are two separate pieces of hardware. So we still achieve isolation, and we still achieve the fact that in case the payment transaction microservice or the payment transaction database is down, well, we can still serve read, you can still browse your transactions, because the replica is likely to be up. So you can still do all the read operation, the application is not down, even though the main database is down. Another point that I want to make is a number of Azure services have a VNet service endpoint. So a VNet service endpoint, if you don't know, is a feature of Azure service that make a managed service that runs somewhere else in the cloud, managed by Microsoft, appear as if it's local to your VNet. So what's the benefit of that? Well, first, it makes it easy to reason about security, especially if you work with a team that's, that has the traditional view of security, of secure perimeter, and everything that's inside is safe. So it makes it easier to reason with these people. On top of that, I can put that NSG you see on the corner and block every single traffic in and out my VNet, because I don't have to allow inbound or outbound traffic to connect to all the managed services, right? They all look like they are inside my VNet. So I can block everything in and out from that VNet, and then I have total control about what's going on there. So that's an additional point related to isolation and security. And of course, the service is deployed in Kubernetes, so I can scale out different services. I can increase and decrease the number of pods, and that helped me approximate my usage much more closely than I was able to do with app service. And of course, when the when the feature of AKS will permit me to create a perfectly private cluster, I can add that NSG over there, and I can replicate the same logic of I block all the traffic in and out of my VNet, so I block all my traffic in and out of my Kubernetes cluster, and then I will add an additional layer of security. And this is important. Like in all, if some of you works in a financial service, you never have to have only one layer of security. You have to repeat exactly the same control over and over and over again, and it's never enough. Yeah, so that's all I had to do about services. Let's move to the journey that we had to pick our transactional database. Like, as I said, we started, we went live, and then we overgrown our requirements and also for the transactional database choice. We started with Azure SQL, mainly because it was what was available at the time. It was working, it was fine, it has a very rich ecosystem of tools to do monitoring, tuning, management, beautiful. The thing that prompted our change in a case was it wasn't very easy to find developers that had deep experience with this thing in our geography, right? So our developers who were experienced with Postgre and MySQL, vendors that we acquired to implement part of our software were experienced with MySQL. So the move was straightforward. We try out a couple of options. Again, we make the same mistake. We never learn. To go to MySQL on VMs. Again, same problems that I just mentioned before. And then we finally settled for Azure MySQL. So again, it was very good, although we were very early adopters. So Sudhakar mentioned that they released this like a year ago. We started using it, I think, 14 months ago. So yeah, and it wasn't quite ready for prime time. So we had to work with them on 3 areas, mainly. The first one is tuning. Not of the database, but of the database servers, and try to understand which parameters they should expose for us to tune and which one we should let them manage. The second area is everything that's related to housekeeping, so creation and management of backups, read replica, and things like that. And the third thing is roadmap. So we gave them like a very big wish list of features that we had on MySQL, and we wanted to see on MySQL. And sometimes a vendor tells you that you can influence the roadmap, and this is not really true. Well, in our case, it was kind of true. For instance, one of the things that I lament a lot with Peric is that we don't have Performance Insight. What is going to show you what Performance Insight looks like in a couple of minutes. So without further ado, I give the stage to Peric, and he will give you a deeper overview about the journey that we did and the work that we did together to make Azure MySQL ready for prime time.
Thanks, Alicia. All right, my name is Parikshit Savjani. I'm one of the program managers in Azure Open Source Database team. So I got an opportunity to partner with HSBC to help them achieve the performance and scale for the mission-critical workload which they were running. So in the next section, which we plan to take you through the learnings and share the best practices which we uncovered as a part of this engagement and this exercise. So HSBC team had very clear goals and objectives which they were looking for from their database service. Any queries against the MySQL database should run within less than 100 milliseconds, which also means any transactions on the database side should complete within 100 milliseconds. And the database service should scale seamlessly up to 10,000 queries per second, right? Now, this is where the Java developers which they had started coding. This is the same familiar MySQL service which they are used to, so that there was no ramp-up curve for them. They quickly started developing the service. They individually tested their queries and their modules and the microservices. Everything was completely working fine, completing within less than 100 milliseconds. So all things were good. Individually, and take the note of the word individually here, individually, they also ensured that this database service can scale. And normally when you come to these conferences, you would see we will scroll the slider and services can scale seamlessly, right? That gives you confidence that, hey, things are working fine. My cloud will take care and it will work great. In addition to that, they had competitive pressure to go to market fast. They had their competitors who were kind of penetrating into their market, disrupting the market, and there was a huge pressure. So let's go back with the series of events. Developers, code complete, they checked everything individually, the module, and the queries are working fine, completing less than 100 milliseconds. They know Microsoft Cloud can scale seamlessly, things would go fine. They have shorter time to market, huge pressure to go out, release it quickly, and then what is the next obvious step would you expect? To go live. But there's one important thing which I want to highlight here. The cross-functional performance and scale testing is of uber importance. Like when an individual developer completes the code, runs the query, it runs fine. But it is important for you to run stress testing with all the workflows at the same time, running at the same time. And I'm glad HSBC team didn't cut the corners here, did not cut the corners here in spite of the competitive pressure. So the key takeaway message, which I want to take you back from this session is, before you go back, feel confident, and go back to your management, give a nod, hey, we are ready for production, I want you to remember that testing is important, right? So HSBC team did that. They ran all the JMeter testing of all the workflow. They were able to simulate their peak holiday season workload at the prime time. And for the peak workload, so some of the things which they noticed was the workflow response time was going up to 5 seconds. This was clearly not acceptable for them. And if you think about, if you're running a mission-critical service which has an end customer-facing experience where your trust and brand is at stake, you don't want to cut corners on the testing. So now let's come to the second part of the problem. Now these were Java developers, and while they have experience working with MySQL, they're really good with MySQL, on the service side, they need help to understand what queries are going wrong. And when you're writing an individual module, it's very easy to debug the queries because you know what module, what queries are being run. But when you're running all the workload together and testing, you don't know which queries are running slow. So the thing which you need is query performance inside. And this is the quick learning which we had on the service side. And we prioritize that feature. And here, this is where I can quickly show you how the experience of the query performance inside will look like. So we are still currently in the private preview, but I want to make sure I show you this demo. All right. So when you're in the Azure portal, this is your blade for MySQL service. And here under intelligent performance, you will see something called as query performance inside. When you click on this, you will see all the queries, long-running queries, which are running on your system, right? And you can prioritize the queries based on like top 5, top 10, top 15, which you want to troubleshoot and go after. And you can also go back in time. And this is the value which we provide on our service. If you see, this query store capability is not available in the community edition of MySQL. So this is a value which we can provide, that you can go back in time and identify what are the long-running queries and see and establish a baseline and see if there is a regression in the queries. And we're planning to do something more to and add more value as well. So keep an eye on this feature. So here in this case, as you would see, in the last 24 hours, I had some run yesterday. This is a workload which I simulated yesterday. And then a developer or a DevOps guy or a DBA would navigate and identify what are the top queries which are running on my server, on my service. And if you also want to identify what are the top queries which are executed most, and normally when you're troubleshooting, you want to combine these two, the queries which are executed most and the queries which are running slower, because that will give you the maximum impact, right, if you go after that. So in this case, if you see, I have query ID 622, which is running slow. Now, next step, you found which queries are running slow. The next step is you want to know why those queries are running slow, right? So then you go to second tab to understand why the queries are running slow. So you go to wait statistics, and the same query ID 622, I'll wait for it to load. So this is query ID 622, same query. And if you see here, so this is waiting on I/O. So if you're familiar with the wait types in MySQL engine, so this is the InnoDB storage engine I/O processing wait type. So it's spending a lot of time on the I/O, and that is the area which you want to troubleshoot and go after, right? Now, so we learned which queries. We learned why they are running slow. The next thing is, now how do I ensure and solve this problem? How do I improve the performance of the query? So for that, the new feature which we're working on, this is already out there, is your advisor sitting inside your MySQL engine. And this is a machine learning-based model which is keeping an eye on the patterns of the queries which are running and giving you personalized recommendations for your server and the service. So when you click on performance recommendation here, so for the same query ID 623, I have 3 recommendations for 3 indexes, right? So this tells me that I can optimize my query using these indexes. So you have an option to quickly copy these indexes and go back to your MySQL workbench. So I have already copied these the queries. So in the interest of time, let me quickly show you how the experience would look like without the indexes in place first, and then with indexes if you follow the recommendations. So I'm running the query. I'm flushing the query cache so that it's a cold cache, so I/O will come into play. There is no memory caching in play here. And without any indexes, if you see here, it's taking around 2.9 seconds or 3 seconds to run the queries, right? Now, let me go and build those indexes. Now, these are huge table, so I don't want to create the indexes now, but I have pre-created the indexes here. So these are the 3 indexes which I have taken from the script here, and I have already pre-created them. So I'm doing the same run again, flushing the query cache, ensuring no memory, no data pages or buffers are cached, so I/O will be incurred, refreshing the stats just in case, and then running the query again. So if you see here, it completed in around 78 milliseconds or so, right? And a quick check to validate your plan, just to make sure it is using the indexes. If you see here, we are using the indexes in the execution plan. If I were to run the same query or execution plan here, if you see here, they're doing a full table scan. So this is your recommendation engine, which is running inside the service, which will give you recommendations for indexes, scaling up, scaling down, and all those things, right? So let me switch back to my presentation. So in case of HSBC, what we noticed was the queries were very well tuned. The indexes were in place, so that was not part of the problem. But we did notice at the peak load, and they were increasing the test workload in steps. So at the peak load, we observed that there was waits on I/O, which means they were throttled by the storage I/O. They were hitting the max limits of the storage I/O, which was offered on the service. Now, this is where, before you throw more hardware at a problem, we wanted to first see where we can optimize the I/O running on the service. By the way, they were already running on our max available SKU. So they were running on our 32 vCore memory optimized SKU, so highest available SKU. And they were also running on 2 terabyte storage tier, which gives you up to 6,000 IOPS, right? So they were already ensuring that while they are scaling up their workload, they were also scaling up the databases in steps, right? But we wanted to make sure, can we optimize further for I/O? So this is where we've used some of the MySQL recommendations. So first things, server parameters. There is a parameter called enodb file per table that allows you to have separate files per table and a separate I/O path. So when you turn on this parameter and reload the database or create the tables after that, and by the way, this is also recommended by the MySQL community, that if you need to turn on this parameter to optimize your database workload performance for I/O, right? Next, slow query log. Now, slow query log is normally used by developers or DBAs to troubleshoot performance. But the challenge, and HSBC team did that because there was no query performance inside at that time. The challenge of that is you will incur I/O overhead when you're doing testing. So if you're turning on slow query log, there is a significant I/O overhead of running the query and logging the query overhead. So we turned that off. And now with query performance inside, you don't have to turn that on. We don't rely on this feature. So you don't have to run this expensive query logs. And if you really want to do, if you have to do it, you would do it on dev test environment and ensure the thresholds are set too high so that you log only the queries which are running slow and turn off log queries not using indexes. There are many heap tables which are shorter tables. We wanted full table scan for them. It was intended because maintaining indexes is an overhead also. So we want to make sure it's turned off. The next thing is moving the audit logs into Azure Blob Store. Because it's a payment transaction application, they do a lot of audit logging to meet the regulatory compliance reason. And it was important for them to move those audit logs, to keep those audit logs, but we could maintain them outside the database. Next, batch transactions. Now, when you're writing queries, you would normally commit more frequently. That's a recommended best practice to avoid blocking. But the challenge is every time you apply commit, there is a flush operation at the database end, the log flush operation, which will incur I/O overhead. So when you look at the grand scheme of things, you want to ensure that you batch transaction from an I/O perspective, and we had an opportunity to do that, and that further optimized the I/O. And lastly, there was some opportunity on the service side. We had some learnings where we could add resource governance and further throttle the backup, automatic backups on the service side, which further helped them and give them more I/O bandwidth. So all these things together ensure we squeeze every ounce of the I/O which we have, and they can sufficiently scale up. But now, when you're designing the architecture using the cloud-native services, one of the approach which you always want to take is scaling out. Scaling up, you're bound to hit some limits. And when you're planning or designing applications on cloud, you have to think about the scaling out diligently there. And microservices-based design architecture gives you that flexibility. So the diagram which Alicia showed you, where they could have an independent microservice connecting to the read replica, and you could actually now you're getting twice the resources which are available from the single server. So we had 6,000 IOPS with one server. With two servers, you have 12,000 IOPS. And an added benefit is, as Alicia mentioned, high availability and isolation. So even if one server got tripped off, it was restarted for some reason, the other servers don't break. So you avoid single point of failure. Another point, for them, for regulatory reasons, they had to do long-term retention backups. So they used to do MySQL dump. And if that is run against your production server, that will read all the pages into the buffer pool. And that can disrupt your performance. So you cannot get predictable performance if you were to run that. So they use read replica to offload that logical backups. And that further helped them scale. So again, scaling out is the key here. Next, when you're running latency-sensitive application, you want to cut down each and every overhead which is there in the path. And some of the overhead is opening and closing the connections, right? So one of the best practices which we had in place already by these folks were using connection pooling. For Java-based application, Hikari connection pooler, it's a lightweight connection pooler, very popular in the community. They use that. What we did was we increased the statement caching. This ensured the prepared statements are cached, and we could reuse the handles more frequently. The default numbers are too conservative, so we increased the cache limits, so that can save some compilation, recompilation time as well. The last, which is the most important point, it is important for every developer when you're developing your service on cloud, is to always have a pessimistic approach to plan for failures. So you need to have a retry logic. And this is not specific to MySQL service, but it's even more important when you're thinking about databases. You need to have a retry logic because there could be a scale-up, scale-down event where a transaction is in flight and it has to be shut down. In addition, there is a patching activity which we do on the service side, and there is a momentarily failover wherein few seconds it will take for you to connect. And every transaction which you're doing has to have a retry logic. This is a key thing to keep in mind, especially when you're running mission-critical service, right? So, and the next important thing is exponential backup. If you don't have exponential backup, when the server comes online, you are flooding the server with the connections. And there is no breathing room, and you would run out of sockets. So it is important that you have an exponential backup logic so that you give some breathing room when the server is coming online, the connections would gradually increase, and then you can warm it up, right? So again, few important things to keep in mind. So now let's talk about roadmap. How are we further improving this service by working with our customers and in partnership with them and learning from these experiences? First, storage scaling up to 20,000 IOPS. So this is 3 times more than what we support today. And we will support up to 16 terabytes hardware. So now, even if you don't want to or cannot afford to optimize for I/O, you can scale up easily at any given point in time. Snapshot backups, we want to cut down any overhead which is taken from any of our maintenance service. And snapshot backup will ensure that we further make that overhead of taking backups 0 on the service side, the automatic backups. Cross-region read replica, will ensure business continuity across geographies, and that will also ensure that you have a DR plan. Currently in our service, we have geo-redundant backup, which is a cost-optimized way to ensure you have business continuity plan. You don't have to provision a server. The backups are replicated across geography. But we want to ensure that if you want to optimize for RTO, and you want to quickly have a disaster recovery failover, then that will happen smoothly with cross-region read replicas. Connection redirection logic. So if you remember the first slide which Sudhakar showed you, you will go through gateway. Now, we want to cut down and make that process even more efficient. So after the initial connection which happens through gateway, in the driver side, we want to make it easy. So you bypass the gateway after that and connect to the server. So that will cut down the latency and further improve the performance on the server. Monitoring supportability, you already saw the demo for query performance inside, performance recommendation. And further, we are continuing to see more pattern and add more ML models to give you regression analysis and some of the other recommendations as we observe and learn from the service. Security and compliance, AD integration is coming. Database level auditing, one of the common asks for enterprise customers. Long-term retention. So this is where we have partnered with Commvault. So is Randy here by any chance? No. Randy is here. So we have Commvault here who is providing long-term retention backup. If you have any questions on that, please come see Randy. He's also there with us in the booth, so he can help answer any of the questions you may have. From developer perspective, MySQL 8, we're releasing that. And the last thing, one of the value for customers to run open source databases on Azure is to seamlessly integrate with the other native services in Azure. And we want to make sure we further integrate with ML. And this is a good segue for me to introduce Barney, who is an enterprise architect with EY, who helped HSBC team to leverage the cloud ecosystem and the integration to deliver more value to their customers and drive user engagement. Over to you, Barney.
Thank you, Parikshit. Can we
take questions at the end?
Just give it 10 minutes. I think probably we're just winding up. Thank you. Appreciate it. Good morning, everyone. This is Barney from Ernst & Young, working with Parikshit and Alizé on launching the product. I'll just directly get into it for the benefit of time. So we are talking about multiple services. How are we kind of tying everything together into a fabric? PayMe is fundamentally a transactions product. We are enabling P2P and P2M. But we do understand in a competitive market, it's more than enabling transaction. It's about bringing more relevance and recommendations to a consumer, which is more than transaction. And for a merchant, it is about bringing much more visibility into a customer behavior, customer demographics, spend category, and everything. So eventually, the idea is to increase the user engagement. It is the success of any social platform, and we see this as a social payments platform. How do we do it? By bringing relevant content. To a customer, it means recommendation. For a merchant, it means sales insights, which are much more than what Acquirers does today. And how do we do it? By having all the data. And as Alizé mentioned, for us, transaction is not just a financial transaction. It is financial transaction plus a friend request, somebody commenting on it. The comment that you mention when you make a transaction, everything is a transaction for us. And we realized fundamentally, this is something that is much more than building a relational database, but to enable links which are not something that visibly stands out of a relational database. So what do we do it? We realize that when you bring all these transactions together, transaction, comments, friends relationship, we happen to see something which is much more powerful through which you can drive user engagements, which is unlike any relational data. While the answer is a graph model, we kind of knew it the other way around. And not to forget, MySQL stores all the transactions data. But we need to kind of take the data, process it in micro batch, and build relationship through which we can answer further transactional question. So we need an analytical data store that can manage micro batch from your transactional data stores, which is MySQL, and provide insights real time by enabling it to kind of query it. So that kind of naturally led us into building a model, establishing relationship, which is not so apparent in a relational data model. With that said, this is one example of what it means, a friend recommendation, like we see in pretty much every social platform, right? Imagine what it means. It's about me trying to find the most common connections between me and another friend and trying to tell what are the top friends that you should go for a recommendation. And this could be achieved by firing a simple GraphQL, which otherwise is going to be pretty complicated in terms of writing a hierarchical query in a relational database, or you having to build an AI/ML model. And that's the benefit of putting data into a model, which is not simply a relational model, but much more like a graph relationship. And we happen to physicalize this in Cosmos. Like any decision that we went through, the decision towards Cosmos is not a straight line. We started with MySQL because we want to use MySQL. It's awesome, except that we realized that some queries are not so native. And then we went with MongoDB. We thought we will run some micro batches, and we put friends recommendation and serve it as a transactional store. The only problem is that I can't aggregate because a MongoDB is not meant to do aggregation operation. Neo4j was apparently a very popular option. Going back to the managed services principle, it's just Cosmos. Again, it still falls under the open source license of using Gremlin API. It's just amazing. So it just happened to solve all the graph database problems that we have. One thing that we have not realized is that we do have about 7 or 8 different MySQL instances. We do have Cosmos right here. There is no one platform that can stitch everything together. So we started with HD Insights, which is a managed Hadoop service. It's really good in terms of batch compute, but it is not meant to run machine learning libraries, which we do have one of the use case. So we end up taking DSVM, which is Data Science Virtual Machine. Together, these two things work good, but the CI/CD is actually a nightmare, and we don't want to really over-engineer it. So we thought, why can't it be an elegant solution? Why can't we go with Azure Functions? Because you can package the jars, and you can run the workload. The only problem is, we deal with about 500 to 600,000 transactions a day in a peak day, and it is just not fitting within the Azure timeframe of 10 minutes backup. And then we went to Azure Databricks, and folks who must have seen this in yesterday's announcement where Cosmos is paired with Spark clusters, we really only wish Sudhakar must have told this to us a year back, because that could have been an elegant solution. But this decision was taken a year back, which is still an awesome product of using Databricks to kind of stitch everything together. And this is just a fabric of how it looks like. Just to give you a picture, on the left, you have like 7 or 8 different database instances. The things that we have not spoken, we do have Event Hub, which streams all the user app behavior. Every button you click, every screen you view, we get an event, which is a user behavior connection. We stream all the data into Azure Databricks, which is on the Analytical platform. We run micro batch. We put the graph data into Cosmos database. And the reason it is positioned between Analytical and application platform is because it's actually a very unique database. It serves as a micro batch Analytical database. At the same time, it answers application queries in less than 300 milliseconds. The friend's recommendation is usually responded in about 300 to 400 milliseconds. And not to forget, we do have a comprehensive machine learning environment, probably for a different seminar, where the data scientist will work on top of Databricks, run their models, pump the insights into MySQL, which is just another application database to be served through using a microservice, the same architecture what Alessio was mentioning. So this is pretty much our fabric. We would like to quickly talk about a simple demo where how we kind of stitch things together. Databricks itself is probably a different conversation, but the idea is that it gives a Jupyter notebook where data engineers and data scientists can come together and collaborate. So this is a use case where we kind of take data from multiple MySQL instances. We have a metadata-driven protocol where we fetch data from about 600 tables dynamically, understand what changed. We move the data into Databricks. We put it into Delta for the folks who know how it stores data. And we have a way to manage libraries, schedule the jobs, execute the jobs, manage the job dependencies. It kind of gives one protocol for us to do it. For the benefit of time, I'm just going through it. This is a simple feature extraction for the folks who are coming from AI/ML background. It's about every transaction when we make, I tell why I made the transaction. And it is very important because that kind of senses the user behavior, why he or she have done it. So the intent of this particular notebook is to know why that particular transaction has been made. We have done an unsupervised learning to find L1 and L2 topics, and we kind of do a supervised learning in terms of classifying all the transactions, and we kind of put that into a MySQL table again to be served by the application. So in jest, this Databricks is kind of a fabric that brings data from all your application instances, read replicas, all the event hub, run a model, collect it, put the insights on top of a MySQL database to be served to the end users. That's about the data fabric by itself. I'll pass on to Alessio for the last few words, and then probably we can take questions. Thank you, guys.
Thank you. So that was very comprehensive description on what we do. So we cover our journey in picking the right tool for both application deployment, transactional database, analytical database, and analytical platform. So how does that come together? If you went back to the results, the technology success criteria that we had at the beginning, we are we are supporting fast adoption and growth. We have 1.5 million customers. They're growing, usage is growing, and we just don't think about growing, basically. We're still fast, 97.9% of all transactions finish within 500 milliseconds, and that's something that we could achieve on clouds only. And we still have almost real-time access of the transactional data into our analytical platform, so that enables a lot of different use cases. So it was a positive experience, the results are great, and we're still growing. So next time we can come to your country, maybe. What are the key takeaways for us from all our experience? Well, I've said them many times, and I know that I sound like a broken record, but we've been very happy to stick to our principle using managed services. They mostly just work. As Parik said, it's better that you test that they work because you can't trust, but you can still have all the control that you need in terms of monitoring and tuning. And when you are an early adopter, you can influence the roadmap. So it's been a bit painful at times, but it's been a very rewarding experience to be an early adopter for that. And we will keep doing that for other services. The other lesson learned is that the isolation of microservice, taken to the extreme, has been very useful. For the technology part, yes, but mostly for our discussions with other internal teams that typically don't have a cloud experience. So if you work in a big organization, having a set of principles and design the same controls 2-3 times, as we did for the isolation of a microservice, helps in all your discussions. So we found it very useful. And the other thing is that although we have the data and we have access to the data in a relational form, not all data fits the RDBMS model very well. So in our case, as Barney shown, we copy the same data into a different model, which is the graph model, and that enables us to create a completely new product line. So now PayMe is not a transactional product, it's an insight product, right? So it's been a very, very, very useful thing to do, even though it took a while, and of course, the complexity that comes with it. So that's our journey, pretty much. If you have any questions, we'll be happy to take it, probably outside of this room because they're kicking us out. But thanks for coming.